Okay, so in lesson 1.3, we're going to be solving equations by using multiplication and division. So, could somebody find, are there any vocabulary words in this lesson?
Solving, multiplying, and division. Any equation.
Okay, sit up for me, Dakota, and then let's try that again.
Equation, multiplication, and division.
Those are vocabulary words? I'm looking to see, are there any vocab words that we need to, that they've highlighted for us that we need to make sure we know? Malcolm, do you have one?
Object.
No, there will be objectives, and we're going to talk about objectives in a moment. I want to know right now, are there any vocabulary words? Isaac?
Distance.
Distance. Okay, what's the definition of distance then?
I don't know. It's highlighted.
It's just highlighted there. Okay. So in that case, it's probably not really highlighted. They're just using the color yellow. He's on page 26. If you guys just want to flip over, where he's looking is on page 26. The word distance is colored yellow. There, they're just using different colors to show the different parts of the words that they're going to use to set up an equation. So it's kind of seeming to me like there probably aren't any vocabulary words in here, right?
Nope.
I can think of a vocabulary word that we had back in another lesson, just the previous lesson, 1.2. We had a vocabulary word called inverse operations. Does anybody remember what inverse operations means? Remember I said, if nothing else, all you have to think of when you hear the word inverse is one word, and it starts with U. Josh?
You said opposite.
Remember, we aren't going to use the word opposite. We don't do the opposite. We do the, go ahead.
Undo.
We undo. And don't you remember back in lesson 1.2, to undo addition, what did we do?
Subtraction.
Subtraction. So subtraction is an inverse operation for addition. Well then, what do we do to undo subtraction?
Addition.
We do addition. So they undo each other. They are inverse operations of each other. Okay, well now, in this lesson, we're going to be starting to solve equations that we're going to have to use other operations to undo. So sometimes a variable is being multiplied by a constant or divided by a constant. Oh, constant was a vocabulary word back in lesson 1.1. Can anybody just give us an idea of what they mean by constant? What's a constant in math? Or can you give me an example of a constant, maybe? What does constant mean in your other world then? What's constant mean? Somebody says, you are constantly over and over. It stays the same. You keep doing the same thing, or it stays the same. That's what it means. So in math, it really kind of correlates. It's the same all the time. So a number is a constant. So your age is a constant. My age is a constant. The temperature outside right now is a constant. So if a variable is being multiplied by a constant or divided by a constant, here's what you need to think. Is it being multiplied by a number, or is it being divided by a number? Okay? If it is, we're going to use the inverse operation to get the variable alone. Well, how are we going to undo multiplication?
Division.
We're going to divide. Yep, it's division. The inverse operation of multiplication is division. Thank you. And the inverse operation of division is
Multiplication.
Multiplication. One undoes the other. Okay, so what's one of the objectives in this lesson?
Yeah, we're going to be dividing and multiplying.
Okay, let's look at our books. Tell me, what do you think, everyone? Remember, where do we find the objectives in our lesson? What's one of the places we could find the objective?
On the top.
Isaac, what's one of the objectives?
Aviation application.
Okay, so application is already at the end of the lesson, and we always tend to have an application problem in our lesson. We are going to do an application problem today. Okay, another objective in this lesson. Solve what? Keep going. you can't just spit out one word things. You give me a complete objective. You have a complete objective for me, Malcolm.
Solve one step equation in one variable by using multiplication and division.
There you go. Solving one step equations. In other words, only going to take one step of work that have variables in them by using multiplication or division. So let's get to work doing that. Here's our practice. Number 1. Our equation is 19m equals negative 19. We need to solve that for m. So I am going to let you out of the check problems today, but you need to show the steps of work. And don't try to do everything all in one line where it's all mixed up and you can't really tell what's going on. So first of all, the first thing we got to decide is what's happening on the side with the variable. Is it being multiplied by something, or is the variable being divided by something? It's being multiplied. What's it being multiplied by?
Negative 19.
Look over here. What's happening on this side of the equation?
19.
M is being multiplied by 19. So to undo multiplying by 19, we need to divide by 19. So we're going to show it like this. Would you write it down like this? 19m fraction bar divided by 19. Leave that first problem alone. Don't mess with it. Move down a line. And then negative 19 divided by 19. Whatever you do to one side, you have to do to the other to keep the equation
True.
balanced, to keep it true, yes. Okay. So on this, on the left side, 19 divided by 19 becomes 1. It's like they cancel each other out. So m is now all by itself. Oh, now we get to do what we did. No calculator here. Now we do what we did for today. A negative divided by a positive is a negative. And 19 divided by 19 is 1. So our solution is m equals negative 1. Okay, so anybody have any questions about that? Okay. What's happening in number 2? What's going on? What side of the variable on? What's happening in that one? Did you have a hand up there, Malcolm? Okay, I want to call on people. Thank you. Did you have a hand up, Malcolm?
Yeah.
Okay, what's happening in number 2?
We gotta divide by 3.
We're going to divide by 3 because what? Can you tell us why?
Variable gotta be 1.
Because the variable is going to be alone. And what's happening with the variable right now? It's being multiplied by 3. Yeah. So since it's being multiplied by 3, you have exactly the right idea there, Malcolm. We need to divide by that 3 because that will undo that multiplying by 3. So we're going to divide both sides by 3. Remember, we're going to leave the equation alone at the start. We're going to rewrite it with our division in it. And now we say to ourselves, okay, these guys are going to cancel out. So the x is going to be by itself. Then we ask ourselves, what's a negative divided by a positive? Negative. And then, 5 divided by 3. Is that pretty?
No.
Why not?
Because
It's a decimal because 3 doesn't go into 5 a nice amount of times, does it? So here's what we're going to do. We're not going to change that to a decimal, though. This is algebra class. And in algebra, we like fractions. So we can leave our answer as negative 5/3. Or we can say x, that's the same as negative what, Emerson?
Negative 1.
Yeah, negative 1 and 2/3. We can be either way. Either answer is fine. But we're not going to change it to this. 1.6, 6, 6. We're not going to put that repeating 6 there, in other words. Okay? Because that's what happens. The 6 just keeps repeating.
67.
So let's remember that. So that's kind of why we use the fraction bar to help us divide, because then we can see that, you know what, it doesn't go in there nicely, so I can just keep that fraction bar there, and then I can simplify it if I want to, need to. Okay, what's happening in number 3? X is being divided by 4. This means, no, you're going to stand pretty soon. If X is being divided by 4, If x is being divided by 4, how do we undo dividing by 4? Isaac?
We have to multiply 4 on both sides.
We have to multiply by 4. So here's how we're going to show multiplying to this equation. Again, we're not going to do it in the original equation. We're going to start another line of work, and we're going to show that we're multiplying both sides of the equation times that 4. So see what got introduced? We multiplied by 4 on both sides. That's what changed. Doing the same thing on both sides. Because guess what happens when you have a 4 upstairs and you're multiplying and you have a 4 downstairs? What do? They cancel each other out like that. So we have x equals, positive times a positive is a positive. Oh. It's been a positive times a positive all your life until you get introduced to negatives. And we're at positives times positives. In the multiplication tables, is a positive times positive positive? And what's 4 times 8?
32.
32. So our solution is x equals 32.
Wasn't that number 3? You said number 4.
Oh, I'm sorry. I meant number 3 if I didn't say number 4. Okay. Anybody have questions? Okay, then let's look at what's happening in number 4. What's going on?
Division.
Division. N is being divided by
5. Negative 5.
negative 5. Is that negative sign important?
Yes.
Yes.
So what are we going to do to both sides? Undo division. We have to multiply. So we multiply times negative 5 on both sides. And these are the kind of steps of work you're going to show. The original equation, the one step of work, that's what we just wrote right now is our one step of work. Because remember Malcolm said we're in the objective, we're going to solve one step equations. And we get n equals a negative times a positive is a
Negative 1.
negative, and 5 times 20. 5 $20 bills is
100.
100, yeah. So negative 100. Okay. Questions about that one at all? Okay. What are we going to do in number 5? What are we going to do in number 5? Ian? Divide by what? We're going to divide by 15 because C is being multiplied by 15. So we write the problem down and put a fraction bar to show division. And what happens on the left side? Well, nicely, like we wanted to, 15 divided by 15 becomes 1. So that's a good thing. We have a 1C like we want. Huh. How many times does 15 go into 5?
30.
Zero.
No. It doesn't go in there nicely, does it?
No.
No, if it was the other way around, 15 divided by 5, then we could say 3. But it's not that way. It's 5 divided by 15.
Yeah.
So we're going to have to leave it as a fraction. And then ask ourselves, can that be simplified?
Yes.
To what?
Divide by 5 or by 1/3.
Yeah, divided. If each of them is divisible by 5, so it can be simplified to 1/3. Can it? So C is 1/3. Again, that's not a pretty decimal. We don't want the decimal answer. Okay. Okay. The next one's kind of tricky only because notice what's out in front of our A divided by 2.
Negative.
There's a negative sign there. So you got to hear me on this because this is going to be really important this year. All the time in lots of things. You got to hear me on this. That negative sign out front of a fraction. There's 2 parts to that fraction, aren't there? So which part is going to be negative? Both of them?
Both.
The A? The 2?
I'm saying
Okay, let's remember our division rules. Let's remember what happened yesterday when we did a positive divided by a negative. What did we get? A positive divided by a negative is a negative. What's a negative divided by a positive?
Negative.
That's still a negative. When one of them's negative and the other one's positive, the answer is negative. So it's kind of like saying here, if you could do the division, The answer would be negative. So only one of them can be negative, right?
A.
Well, you know what, we want a nice A, we don't want a negative A, we want a positive A, so let's give that negative sign to the 2. You can give it to either or, but it makes more sense to give it to the 2 so that our A stays positive. And that's all we're doing in that step. We're assigning the negative sign to either the numerator or the denominator. We chose the denominator. Now what are we going to do to both sides?
Multiply -2 on both sides.
We multiply both sides by -2 because A is being divided by -2. We have to do it on both sides. And these guys cancel. We have A, negative times a negative. 2 times 4, 8. A equals 8. Negative times negative, positive, 2 times 4, 8. That's what our brain should process, okay? Anything you're concerned about here on this side, we'll go to your application problem. Anything we need to talk about? Don't want you to get stuck in your homework. Okay, I guess we'll go to the back side. You're so excited to do that word problem back there. Let's go.
We are?
Oh yeah, everybody's turning their paper over. Okay. Who would like to read this out loud to us nice and clearly and loudly? I'm sorry, Isaac, we've heard enough from you today. We want you to rest your vocal cords for a little bit. Thank you though for offering. Okay, Greg.
Peter mailed a package from his local post office in Valley City to a friend in Fargo. The cost was $2.76. The first class rate was 23 per ounce.
23 cents, that is.
Write and solve an equation to determine the weight of the package.
So let's visualize this. Here he is. Peter's at the post office over here. He's sitting at the counter and they put his package on the scale and they weigh it and they say, if you want to go first class, it's 23 cents an ounce. And he's like, okay, I want to go first class. I want you to send it first class. And then they say, okay, it's $2.76. What's the thing we don't know?
Wait.
We don't know how much the package weighed, do we? So remember, what's the first thing we always are going to do? We're going to say, oh, what variable are we going to use and what does it represent? So what variable do you want to use? In. Here's the deal.
S.
If you're not going to use X, typically you use the first letter of what you're looking for. So W or X? W for weight or X?
W.
W. Okay, let's use W. W is the number of what?
The number of.
Remember, it's weighed in, it's charged
Ounces.
in ounces. So it's the number of ounces. That's how much the package weighs in ounces. Okay? Well then, we need to do our next step, which is set up an equation. Well, what did they do at the post office when they said to you, they put your package on that scale and said, it's $2.76, what did they actually do to get that?
Multiply 2. No, they divided it.
Why do you have to put on a scale?
Why do you have to put it on the scale? Because they charge by the ounce. That's why. So they have to set it on the scale to see how much it weighs. So what algebraic equation can we set up that shows what they actually do to get the answer?
Divide 23 cents into $2.76.
Okay? That's one way to do it, but I don't want to make it a multiplication problem. I'm just feeling like multiplication to start with here.
Wouldn't you multiply the $2.76 by the 23 cents?
No, you wouldn't take the total amount of the bill times the 23 cents. It's 23 cents for every ounce. And W represents the number of ounces. So wouldn't we take the 23 cents times the weight? 23 cents times the W? If I say to you, I'm going to give you 5 cents for every pound you weigh, how would you figure out how much money I'm going to give you?
Divide 1 by how much?
Yes.
5.
You'd figure out how much you weigh, and then you'd multiply by 5 cents, right? And then you'd be like, Mrs. LeGrand, you owe me this much money.
I
Only
agree.
$7.13 or whatever it comes out to, okay? 4 on the floor, let's keep those 4 feet of that chair on the floor, okay? Thank you. And this is equal to $2.76. Okay, what's our step of work to solve this?
Divide.
Okay, remember we don't show that in that, that's our equation, this is our work right here, we're gonna divide by 0.23. And now I will let you use your calculator. Now I will let you use your calculator to get what, $2.76 divided by 23 cents.
I got 12.
12?
Yes.
Okay, it's 12. And that's 12 what?
Dollars.
Ounces.
Ounces. Remember, W is the weight, the number of ounces. It's the weight in ounces. So we have a 12 ounce package. Okay? Now, remember we answer though, our final answer is in a sentence. The word problem is given to us in word sentences, we're going to answer it in word sentences. So what are we going to say?
The weight of the package is 12 ounces.
Oh, there you go. The weight of the package is 12 ounces. Amen to the application problem. Okay, now is that the only way to set up the equation? No, Dakota actually had another way that would have gotten us the same answer. In fact, it would have taken us to the work step of our problem because Dakota said, can't we just do $2.76 divided by 23 cents and that will give us the weight in ounces? Because isn't that what we just did? It is, isn't it? So there are oftentimes more than one way to set up the equation, but then there's also ways that don't work, like somebody saying to me, let's take $2.76 times 23 cents and set it equal to the weight. That wouldn't have worked. Okay. So, okay, then let's get out your loose leaf paper. On that your loose leaf paper, you need to start with a heading. Oh, you're grinning. I'm gonna be.
You're looking at me. Well, it's funny when you say it's an emergency because it's personal.
Go ahead.
That would be a target.
Okay, heading on your paper, the first line of your heading is your name, and the other 3 lines of your heading come from the board right here, yes. And you need to show the kind, keep your notes up, you need to show the kind of work we showed in our notes.